Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Aimizarith Imran bin Muhammad Rizal. So today I want to talk about my group assignment for static. Firstly, what we need to do is our group need to choose a system for these assignments. So we decided to choose a ladder for this system. So here we conclude with the photo of the system with the person as the weight for the ladder. So assumption for this system is a person weight is 60 kilogram, ladder weight is 2 kilogram, and then the length of the ladder is 15 meter. So we will continue the presentation of free body diagram from Nuryn.
Assalamualaikum and hi, my name is Nuryn binti Muhammad Yatim. I will present about why force with action on FBD with my partner Aimizarith. As you can see, this is a FBD that we got from picture of original structure. A ladder is leaning against the wall. At the base of the ladder, there are two forces acting, the normal force on the floor and on the ladder, and the frictional force. At top of the ladder, there is a normal force due to the wall.
I will continue Nuryn's presentation. So I will talk about the gravitational force. The gravitational force is acting at the center of the ladder. They are torques due to these forces. If the angle is large, the net torque and the net force are zero, and the ladder is in equilibrium. If the angle is too small, then the ladder will be no longer be in equilibrium, and then the ladder will fall.
A very good day. My name is Darshan and my ID number is B09201037 and I'm from class Bmmh 1/1. And today I would like to continue with the presentation, which is basic theory calculation for the mini project. And on the right hand side here, which is the FBD diagram. So on the right hand side, the arrow shows the work force, and there's two arrows downwards, that is the gravitational, and upwards the arrow which is facing upwards is a gravitational force, and the arrow which is facing towards the left is called the frictional force. So now I would like to talk on how to get the gravitational force. So therefore the sum of fx equals to 0, which work force minus the frictional force equals to 0. Therefore the work force is equivalent to the frictional force, and for sum of Fy equivalent to 0, therefore Fg minus 2 times by 9.81, which you will get negative 19.62, and minus negative 60 multiplied by 9.81, you will get negative 588.6. so therefore negative 19.62 and minus 588.6, you will get the value of 608.22 newtons. So that is how to find the value of gravitational force. That is all from my part, and now I would like to pass it on to my group member to continue this presentation. Thank you.
Okay, Assalamualaikum and hi. My name is Khairil Fitri bin Amin, and my matric number is B0920100147. Alright, today I would like to present about basic theory calculation for moment. Alright, for moment, we calculate the moment at point ground, which is this point. Okay, first step, we need to resolve all these three force wall, force ladder, and force person. Okay, first Fw cos 27. So how do we get this 27 degrees? Alright, first we know that this angle is same like this, 63. So we need to minus 90 degree with this 63 angle. So we will get 27 degrees. Alright, and then 19.62 cos 63. Alright, 19.62 is for the ladder, and 588.6 is for the person at this. So after that, we need to multiply by the length of this ladder. For this force wall, we need to multiply by the 15, because from the point ground to the point this force wall is 15, and for the weight ladder, we will put the weight at the center of the ladder. So 15 divided by 2, we will get 7.5, and then this 3.75. This length is from the ground to the person is 3.75 meter. Okay, so FW cos 27 multiplied by 15 minus 19.62 cos 63 multiplied by 7.5, and then minus 588.6 cos 63 multiplied by 3.75, and equals to 0 because this condition is in equilibrium. And then we arrange until we get this W force for wall. At the previous slide, we know that force friction is equal force wall is equal to force friction. So force friction equal to Newton multiply by coefficient of friction. So we put this calculation and rearrange until we get this coefficient of friction. So the coefficient of friction for this ground is 0.131. So that's all for me. Thank you.